my name is Brian and I'm here to hack. We're going to do some work on the Tiger Beetle Rust client. Tiger Beetle is a financial database written in Zig. It has clients for all the languages you'd expect, but not yet Rust, so we're making a Rust client. Give me 1 second while I tweak my monitoring. Alright, so on this stream, we've been building a Rust client for Tiger Beetle entirely on stream, front to back, over many months now. And recently I'm working on rework for our initial pull request. Kind of at the end of that rework, but we're doing, every little single thing on stream, so it's kind of slow going. Last time we did, what did we do last time? We were working on the representation of the data types involved in the REST API, making them ABI compatible with the underlying Zig types, at the preference of our reviewer and at the preference of Tiger style. In Tiger style, we have some core data types that have a defined representation, and they're kind of used all throughout the stack in the core database engine, as well as the protocol, as well as on the clients. So, what you see is what you get in Tiger Beetle, even all the way at the edges of the clients. And so we did some work on the ABI in Rust, and we're almost at the end of all the rework on this pull request. Today we're probably going to go look and see if we have any new comments on that pull request that we need to address. And then we need to do either a rebase or a merge, because this PR has been in the pipeline for several months now, and some internals have changed, and we need to go make sure our PR still works on master. And then also our PR has some failing CI tests, which I've not even looked at yet because we've had so many other concerns to address on this PR. But, those things, get those addressed, and then maybe we'll be able to say, like, we think we're done, please consider merging this. And then even after we merge this PR, there's still going to be, quite a bit more polish left to actually get this into the production phase. All right, let's go real quick and look at our pull request. Just see if our reviewer has given us any more food for thought. All right, here's the pull request. And let's see. Okay, so last time, this is what we did. This is all about the ABI and how we're representing structs. And I'm trying to kind of make this code accomplish what our reviewer wants, which is to make the ABI look like the underlying Tiger Beetle ABI, and not have any conversions between the Rust representation and the underlying C representation. And that was a bit of a problem last time. We kind of did what he asked here. So we made it so, like, when we pull in the data from the underlying library off the wire, we're casting directly from bytes to the Rust structs that are exposed in the Rust API, instead of casting to an intermediate C struct and then converting to a Rust struct. But still, I left in the definitions of those C structs so that I can make assertions about the representation of the Rust structs, because I want to, have some confidence that the definitions that we've written in Rust are the exact same as the C definitions. So you can see here, our reviewer has said, like, we don't want to have two copies of these data definitions. And I didn't actually achieve that. I got rid of the conversion between the two, but I left the generated C representations of these types in there so that I can make assertions about the Rust definitions. Give me 1 second here. I thought I was going to be able to wear this big heavy cardigan the whole stream, and I was wrong. So you're going to get to see my guns this stream. Pardon me, y'all. Okay, but this is what we posted last time, and we haven't received any new feedback, so that's encouraging to me because I kind of want to move on and get the other things done here. And this is done. I can mark this as resolved. Let me read this real quickly. Okay, this is about the error types here, and I've done this here. Result, create transfer result, or maybe just an OK variant. Huh. Taking a step back here, actually, should not actually implement. Definitely let's remove error. So here he says, so the issue here we're looking at is that we have some status types in the Tiger Beetle protocol. And these statuses are generally comprehensive, like every possible condition about a particular event or request is represented in these statuses. And to make an idiomatic Rust, I massage these statuses a bit so that the OK status is a Rust OK result. You can see right here. So some of these requests were returning a result of nothing in the OK case. But there's a bit of an issue because create transfer result has many statuses, and there are actually two obvious ones that could be OK. There's another one that says exists. Like if you submit the same transaction twice, you know, perhaps on a retry or something, and then one of them, the first one went through, then you've kind of submitted the same transaction twice. If the first one was executed and the second one just says, yeah, this was already done, don't worry about it, that's also kind of an OK status. And so our reviewer asked us, you know, challenged us about that and said, you know, let's add the OK variant back here. And I actually kind of did this differently than requested, and I didn't realize it. I got rid of this outer result. Yeah, so what they asked was to remove error from this type. So this is no longer implementing error. It's kind of in the error position of the result enum in Rust, but doesn't implement error. And the requester was kind of like splitting the difference here about what we could do and what the semantics of this type, result type, could be. Saying, well, let's keep the result type, but not implement error on here. And on the last stream, when I addressed this, I kind of just blanked or something. I didn't understand quite what he was asking for here. And I removed result here, removed error from this error type. So now this is just the only thing returned here. And the user just has to match on it and deal with it explicitly. Can't do as a question mark. So I gotta kind of leave an explanation here real quick. Yeah, I removed the outer result, just returning create transfer result. So the user needs to, you know, match this and handle it explicitly. You know, it was kind of accidental. All right. So that's needs some feedback still. Not quite fully resolved. This is correct. This is resolved. All right, there's no other feedback from our reviewer. So again, here's all our failing CI. And the first thing I want to do now is go merge with the main branch. Just get that taken care of. So we need to, what is going on here? Oh, yeah. So last time when we worked on this, I kind of gave up in a fit because there were some semantic issues around some of our big generic helper functions that I couldn't quite decide on just naming stuff. And I'm going to punt that out completely. I don't think it matters too much. It's just naming ultimately, and those are just internal functions. And so this is just looks like some in progress diff that I just abandoned in the stream. Let's just check out and forget all about whatever that was. All right, are you seeing my screen? You're seeing my screen? Okay. Before we do our big merge, let's do a cargo check and cargo test. Just make sure I'm not in the right directory. This is in the source clients Rust, cargo check and cargo test. Just make sure this all still seems reasonable. And again, I always disclaim this, but we only have one little smoke test so far. One of our big remaining tasks before this can be claimed to be production ready is to write actual tests for this. So this one smoke test, covers all the requests, but it's very cursory. But it's enough to cover our butts if we make any big mistakes while we're doing all this rework. So now we need to fetch origin, the upstream branch. And we're gonna to decide between doing a rebase and a merge. If we rebase, it's probably gonna clobber a lot of our review on that PR. So I'm just gonna do a merge. I don't love merges because they make history ugly. But in this modern GitHub era, nobody seems to care too much about what history looks like anyway. And I think Tiger Beetle does the pretty typical GitHub squash where the entire PR just gets squashed into one commit. So I am going to say, can we do this right now? Are we ready to do this? Let me real quick run format Clippy, just make sure everything is pristine. Oh, something going on here. Ah, that was the diff we just got rid of. What is this? Probably need to figure out this format before we screw anything up. Let's see, what was our last commit? Simplify create packet. I believe this format diff is a result of the last commit. You can see the last commit was simplify create packet, and this is all around calls to create packet. This is jogging my memory now. I must have just failed to commit this last time somehow. So I'm going to amend this. I'm going to force push. Force. I think that's enough to do it. And so we've already got the format done. Now let's see what Clippy thinks right now. I'm really hoping we can get this PR done this week and move on. I would really love to move on to just another streaming project entirely, something in Zig as is appropriate for Tiger Beetle. But this Rust client has, a whole bunch more necessary to finish before it gets to production status. And there's so much more that I think it's going to be quite a few streams yet. And right now I'm doing 2 streams a week, which is, 2 hours per stream or so. It's pretty slow going. And just writing a big test suite is going to be quite a big chunk of work. All right, so we do have some kind of thing here that we missed during our refactoring last week. Iter copy collect is both faster and more readable. Huh. Events.toVec. Okay, this makes sense. Let's go look at this code, 850. I don't even have my Emacs. Tiger Beetle, source, clients, Rust, source, lib, 850. So you can see here, what this is doing is collecting a slice of events. These are essentially requests, but we submit multiple at one time. But each one is kind of a independent request of the same type. And our input is a slice of these things. And internally we're going and collecting them into a vec. Excuse me, y'all. And there used to be a conversion step here, and that's what we were addressing on the last stream. Now there's no more conversion here. We're just kind of like making a copy of them. You can see the great error message as saying, you know, this pattern is not only verbose, but less efficient than just calling 2vec. So this is an instance where Rust's error messages just really shine. Like it recognizes this exact pattern and says, no, here's a better pattern. You know, sometimes I don't agree with Rust and Clippy especially, but this is a really good one. There's like no downside to just doing this instead. Hey, Misanthrope, good to see you again. It really warms my heart that you are always able to stop in and say hi. I really appreciate that. That's comforting. All right, so we just made this little tiny fix here. I'm gonna do a cargo check. So today I'm gonna do the big merge with master today, Misanthrope, and we're gonna get ready to hopefully get this PR merged soon. Got no new feedback this week on the PR. And let's see, I think I can probably, I'm thinking about whether I want to rebase and squash this change into the commit that it belongs to, or just make another commit for it. And I don't think it's worth cleaning up the history for this. I'm just going to say use 2vec instead of iterators. Yeah, I was just thinking, like, is that I put backticks around 2vec, and that's a special shell expansion. That's no good. Git commit amend. All right, I'm going to push that. Now our workspace is all pristine. Clippy's happy. Rust format's happy. Now I can try to merge the main branch. Oh, wow. So I fetched just a minute ago, and it looks like we've already, in the last 10 minutes or so, tagged a new release. So get your new Tiger Beetle now. I'm going to say merge. Actually, before we do this, I don't actually know the thing that has changed on main that is going to break us, but I know something has changed. So let's go do a little reading to try to prep our brains for what we're going to need to fix. Because, you know, the fix, it could be like silent breakage, or it could be compile time breakage. Better to have some information before we go in. So I know this, sorry, I'm breathing right into the mic a lot. Bad mic discipline. All right, so this thing, I got the heads up that this is going to break me. TB client. All right, so changes to the TB client, which is the library, the Zig library we're binding to. And it's not thread safe. This doesn't really apply to us because, like, we're using Rust type system to make whatever's going on in TB client thread safe. So this is fixes for the lesser languages. Submit can be called for multiple threads. Dinit requires synchronization. We can't submit after dinit. Results in undefined behavior. That's a interesting claim because there's multiple languages involved here, and the definition of undefined behavior is different between languages. Give me a second. I'm back. Spring came early here, and I'm just very, very congested. It's not super comfortable for streaming. All right, so usually we have a mutex around this thing because there's an internal mutex and other languages have their own mutex. Client handle is an intrusive struct. Includes a vtable with function pointer. Okay. Intrusive struct client interface. Yeah, not fully grokking that right now. Doesn't seem like it'll impact us. Okay, this actually sounds like it could be quite disruptive. Idiomatic Zig API and TB client exports. Ugh, this sounds like it might be a big task, y'all. Reworked the build script, updated clients. Next steps. Logging callback. Yeah, this is something we haven't even touched within the Rust client. Make the C client first class. Okay, we're gonna have to, lots of commits here. Yikes, okay. Let's look at these. Hopefully this is structured in a way that we can just read it. Add lib tbclient.zig. Empty file, nothing. TB client exports, just moving stuff from, okay, this makes a lot of sense. This TB client exports was just kind of like an outlier just sitting in the main source code, and now it's been moved into the client source code. Rework the client interface. This is probably the big one. This looks like the same text as in the PR. Okay, client H, this is generated code. So this TB client T is just an opaque struct that probably contains, a pointer to whatever internal vtable the op was talking about. TB packet has changed. That affects us big time. So TB client, already we're just treating it as an opaque handle to something. TB packet, though, we touch a lot in the Rust code. And this diff is not easy to read. Let's just count the fields here. 1, 2, 3, 4, 5, 6. TB packet is at the protocol level, so I'm doubting it's actually changed. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, didn't actually change, just moved around. These status enums, if those change, it's kind of bad for us because we don't have any tests in place that verify them. That's one of the things we have to do later, is make sure we have like tests that reflect over the C definitions and ensure that the Rust definitions are exactly the same. But again, these are all protocol level things that I doubt changed. I don't recognize this TB client status, though. I guess this is related to this kind of new thread safety that they're adding. There's a question in chat about whether I play video games. Off topic. I like video games, and I follow video game tech, and I watch other people play video games, but I play video games sometimes. I play video games sometimes. The most recent video game I played was Indiana Jones, the new Indiana Jones game, which I liked a lot. I always love those kind of, what are they called? In immersive sims. I'll usually play for a few hours through them and then like appreciate them, and then I hardly ever finish a video game. I also recently finally played Mario Kart 8. whatever the latest Mario Kart is, 8 or 9. I've been eyeing Mario Kart for years and years and years and just finally bit the bullet and played it. I would really love for a new F-Zero to exist. But I don't play a lot of video games. They don't hold my attention much. So I often think when I'm playing a video game, like I could be creating something right now. But then instead of creating something, I'll go watch YouTube. You know, something really mindless, completely mindless, instead of playing a video game. All right, I gotta keep trying to think here. All right, so this TB client status is probably related to this PR about making client thread safe on dinit. So probably what happens is if you dinit, it like puts a little invalid status that kind of is a guard. Like if you do anything further after dinit in another thread, it'll catch that and say, nah, you don't have a valid client anymore. So we're gonna have to be aware of that. Log levels, not really mattering to us right now. Again, the PR mentioned that logging is kind of not really done yet, and we don't we don't touch the logging facilities in the Rust client at all. Miss Anthrop, you're still playing WoW, huh? That's impressive. I played WoW a long time ago. I really liked it. I played I don't even remember what they're called. The zombie guys. I played one of those zombie guys in the Horde. And I really liked playing the old school, the PvP arenas, especially the capture the flag ones. I just basically just captured the flag all day in WoW. But it's too intimidating to get back into. Every time I've tried to get back into WoW, it's huge and the world is empty. TB client init. Okay, so here's our constructor for TB client. You can see now it no longer returns TB status, it returns init status, which is kind of interesting because like you would think like on construction, surely the status is okay. Like you're not going to have an already de-inited value on construction, but you can see here that the pattern that Zig often uses is that you need to create an uninitialized object and then call the constructor on an uninitialized object to initialize it. And probably the reason this could fail is because you're reinitializing a de-inited object, or maybe reinitializing an already inited but not de-inited object. Medlingo is in the same boat as me. Just always feel guilty about wasting time on video games and then don't spend that time productively anyway. That's me. That's totally me. I'm a procrastinator. I have been lately I've been learning guitar, and guitar is pretty awesome because I can watch YouTube and waste time while also doing just drills, like kind of mindless mechanical drills on guitar. And that's nice to be able to multitask. All right, let's this TB client init. This is just a formatting change. And remember, this is all generated code. But otherwise, this all looks the same. Are these arguments of this callback the same? I think so. No. All right, there's an extra argument to this callback. That's important because in Rust, this will be unsafe. We're going to have to unsafely create this unsafe function, basically, for this callback. And this argument list is changed. Let's bank that in our minds for the future. This init echo method we're not actually using right now. I don't even remember what it does. Echoes back. Yeah, this is some kind of like testing interface. I don't fully understand what it does though. Completion context. This looks, we don't use this, I think. Yeah, we don't use this. I don't know. Other languages must need it because they don't have like closures or something, but we capture any state we need in closures. TB client submit also. So every function now returns client status in case it's been de-inited. Otherwise, the arguments here are the same. And in our code generator, so we have a handwritten code generator for all the languages we're creating client bindings for. And the code generators are not super sophisticated. They'll generate, using reflection, compile time, Zig reflection, data types, but at the moment they just splat out handwritten function declarations. So these are all in our Rust bindings generator. These are all just written by hand, even though they're emitted as if they were written automatically. Okay, more just status. Register log callback. Don't care about right now. Okay, that all seems not too difficult to adapt to. Not too difficult. We're just going to have to change the definition of TB client. And again, let's go look again real quick. What was the old? Okay, so TB client used to be a void star, and now it is. It's interesting. It's still just a pointer-sized thing, but it's not a void star anymore. And the ops said this was like a V table, right? So presumably this is still a pointer to a V table, but maybe there's like a sentinel value here to represent that like uninit init status. Like maybe if this is a 0, it represents uninitted. Anyway, we'll figure that out as we go. But so far, the interface has only changed a little, not too big of a deal here. Again, I want to look at this callback real quick. What was this uint pointer? So there's a pointer here, and then this is the TB client T, which is probably containing some kind of magical special pointer. We're guessing. And I would assume this was the pointer to TB client T, but I don't remember. TB client T pointers. All right, here's the code generator for, no, it's not the code generator. This is the entry point for the client library. So this kind of defines the API surface of the TB client Zig library. It looks like it's changed a lot. Let's see if there's anything in here that we can get information from. Again, logging we're just not caring about. Well, this is logging stuff, logging. Oh yeah, everything's changed. Everything's changed. So now these contexts are, wait, T in it. So these are the API functions, the public API functions. They're exposed elsewhere through Zig export statements or export blocks or something like that in Zig. Again, I'm not a Zig expert. I'm always forgetting exactly how things are done. But these are the functions of the public API, or they were. You can see they don't exist anymore. They're somewhere else, probably related to that TB client exports file, which I'm going to go look for. So this is TB client exports. This code looks to be much better organized than it was before. Before, like everything was scattered around, 3, 4 different files, and you had to kind of cross-reference a lot of stuff to figure out what the actual surface area of the TB client library was. And now hopefully it's mostly visible from this TB client exports. And here's our TB client T struct. So this is the handle that used to be a void pointer, and now it's 4 bytes of something. Wait, is that 4 bytes or is that 4? That's 4 U64s. Let's go back up here and look at this real quick. I misread something. Yes. This is not just 4 bytes. So before I was saying, it's still pointer sized. Can't be doing much different, but it's actually 4 pointer sized. It's 4 UN64s. That makes more sense. They're stuffing more information into this handle now. Let's see what that information is. Pointer cast. So this is pointer cast of self. Self is a pointer to TB client T, converting it into a TB client interface. So this is just a TB client interface. So TB client interface is 4 times 64 bytes. Or not 4 times 64 bytes, you get it. 4 times 64 bits. 4 times 8 bytes. It doesn't really matter what's in this TB client interface, but I am curious. But let's, push that onto the stack and come back to it in a minute. This stuff is all unchanged, but now defined in one place for readability. That's nice. Logging stuff that I don't care about. Okay, no, this is so much better. All these things that are in the data types in the C API are now clearly defined in one place, and they're all re-exports from some zig type elsewhere. And these are presumably defined with some stable ABI. Oh, that's beautiful. And here's our public functions. And somewhere there's going to be like an export thing that says what's being exported. But not in this file. It's called exports. Here's where the exports used to be. Where are the exports now? Huh. It could be in a future PR or a future commit. This is just one commit of this big PR. And okay, here's the C bindings code generator. And when we go change the Rust code generator, we're going to need to kind of cross-reference this and adapt our code generator to what they've done here. Export. So here's the exports. Where are the exports? I think this is just yeah, TB client exports. BSR TB client exports. This exports module, it could be this module. Unclear. None of this looks super impactful on what we're going to do. This is all these, again, like I said before, these functions that are part of the API, not actually code gen, they're just kind of handwritten. We're going to have to go modify all those in the Rust code generator. This is going to be pretty ugly because all this stuff just impacts the completely unsafe FFI boundary. And we're going to be kind of just doing it blindly. We're going to have to like say like, okay, this looks like the set of things that we need to change. And then we're going to go run our tests and just hope nothing crashes or that nothing has the potential to crash in the future. This is going to be a pretty nasty change to make. Test C tests. I don't know what this file is even. Probably not that important. Okay, so I didn't see where those types are actually exported, but I got a pretty good overview of what we're going to have to tackle here. Rework the client interface as we just did. Here's the build script. Maybe this is where they make the new exports. This might impact us. We also have a little build script for the Rust bindings. What has changed here? Oh, it's just an addition, a new thing. VSR module. Yeah, so for all these, what is this? For source clients, TB client header to use C import and TB client.h. Don't know. Don't understand. VSR module. So all these tests, this is for test targets, which we don't have one in Rust. The Rust tests are run through Cargo. So I don't think this is going to impact us, but for some reason they have to have a new module for the VSR, which is kind of the core consensus subsystem in Tiger Beetle. All these tests need a reference to that module for some reason. Maybe to access all those client definitions, because the client definitions seem to live inside the VSR module. Client, client has access to a lot of core data types, so kind of makes sense. module add import VSR, VSR options. Again, this all seems test related in ways that are not going to impact the Rust client. I'm not seeing anything here that is super concerning. This might impact us because we build a static library specifically for the Rust client to read. Like all these language bindings, they kind of make similar but slightly different builds of the TB client static library and or shared library, kind of customizing it in various ways. The Rust one doesn't really do any special customization, but they all kind of do their own independent builds of TB client instead of making one shared build for every single language. So we might have to do something like this. And again, if you're just joining us, we're working on the Rust client for Tiger Beetle. We've been reworking our PR for this project, and one of these very last steps is we need to merge with main. And in the meantime, since we filed this PR, there was a fairly substantial change to the interface of that library. So right now I'm just kind of like reading through the PR. There's all our exports that we were looking for. Yeah. We're just kind of reading through the PR that made that change, trying to prepping our brains for what might be involved when we do this big merge. So these are the exports in the public interface of the TB client library. Now lives inside of libtb client. So presumably this is kind of like the root module in Zig for that library. And that library is much better organized now than it used to be, which is great. Some of the stuff, probably not super interesting. It's just adapting all the languages to the changes. Might look at the Go one and just see what was involved there. So you can see the Go client is also using the C generated bindings. I assume this is generated. So they're using CGO apparently. Yeah, and this is just generated code similar to what we already saw for the C bindings. And their C client, they used to have a mutex to deal with that dinit race, and now they don't have a mutex, but otherwise this is pretty similar. They're allocating so their client used to be a void pointer. So they were just having that void pointer on the stack. Now client is an opaque handle, a struct though. And now that's a heap out. In Go, they're heap allocating that struct. In Rust, I don't think there's a reason for us to heap allocate that struct. We'll just put it directly into the by value inside of our client. And then again, all these status situations are going to change. Because the functions all return different types now. Okay, this all looks reasonable. I think this is all pretty straightforward, not going to be too difficult to fix. I think I've kind of learned what I'm going to learn from this PR. Let's just step back real quick and think about, take a drink and think about what we have to do. All right, so a bunch of these, the only type that changed is the TB client handle. And fortunately, it was already opaque, so we don't have to do much there. But we are going to have to change that type definition. And that we might just need to change that type definition. The way we initialize that, because it's just a bunch of opaque reserved bytes on the stack. We have to do something to initialize those bytes, but should be pretty easy. Just probably call default to zero them all out when we initialize them. We have a new status type that we're going to have to define and probably put in the code generator. And we have to put it in the code generator to have the kind of bindings version of it. And then we're going to also probably need to define by hand a Rust version of that client init status. All of the functions in the API return a different status now, that client init status. So every time you call any function, you got to make sure that you got to check that and ensure that your client was inited when you call that function. In Rust, in theory, we're going to use the type system to make it impossible for that to fail, but we'll probably want to put those checks in anyway because the interface implies that they could fail. You need to change the code generated for all those functions. Those are all handwritten. Just have to cross-reference the C generator and do those by hand. And that callback for requests, when you get a final request, when you get a callback on the request, the completion request, sorry, the completion callback on a request, there's an extra argument there. Do I want to go read further about what the deal is with that extra argument? I don't think so. We'll just deal with it when we get to it. And we're going to have to do all this in like one big bang. We can't incrementalize this at all because it's just going to be one big merge. That's a bummer. Although it seems pretty easy. But again, this is all unsafe code. Potential for errors is high. Risky. All right, am I on the right screen? All right, let's go try to do this thing. What I think I want to do is do the merge and just not try to fix anything in the merge. Just get that commit committed. And then in follow-up commits, we'll just try to address all these things and then squash them all down later. I'm going to say git merge origin, and this type of thing, you sometimes like try it once, then back out and start over and try it again until you figure out the right path through. So we'll see how it goes. And I haven't done any research ahead of time. I'm doing all this on stream, so no idea what's really going to happen. The merge though, completely clean, but it's definitely all going to be broken. We can even run cargo check, cargo test, and just see how broken it is. And the reason this merged so cleanly is because the Rust client is all new code. It barely touches the Zig code base, the Tiger Beetle code base, only in the build script. And you can see here, it failed pretty fast. So it failed in the build script, the Rust build script, probably while calling the Rust build step in the Tiger Beetle build. So here's the Rust build script running. And we tried to run Zig to build the Rust bindings, run Rust bindings. And yeah, basically this is in, these messages are, yeah, Zig is pretty young. Hard to read the messages sometimes, but this Rust bindings, also this is going through several layers of build scripts, so maybe some of the colors were stripped out here or something like that, but this is pretty tough to read. You can see the error here is actually in the Zig Rust bindings because it's doing that compile time reflection and it's just all wrong now. So first thing to do is go do our best to fix the Rust bindings. And those live in right here. And to do this, we gotta go cross-reference the C bindings, which live somewhere in here. I think it's still the same name, TB client header. You can see code's very similar. There's a lot of code duplication in these language bindings. But yeah, all this stuff, different. A lot of differences now. So, yep, what we're going to do here is just kind of like one at a time go through these and make sure these all seem to agree. And this stuff looks like I can probably just copy paste these, but I'm curious. My lines don't quite line up here, so I'm having a hard time tell if this set of things here is exactly the same. You have account flags, account, transfer flags, transfer. Yeah, these all look identical. So this is just completely replaced. You can see before, the bindings were taking those Zig named types and converting them to CNAME types. And now the TB client library itself is giving us sort of canonical C names for a lot of these types. Although we're still converting like Zig style flags into C naming conventions for the C enums. So it's not fully one-to-one with the C naming conventions, but closer. But that looks correct. Now this TB client T has changed. TB packet we've got already, but we're probably going to want to adapt all this on the Rust side, on the old Rust side to look more like the new C side. This struct must be pinned, not copyable or movable. Not movable. That's why it has to be on the heap. So in Go, we said we saw this was on the heap. Interesting, not movable. I guess that makes sense. That means we're gonna have to put it on the heap too. Or we'll probably put it on the heap. That's just the easiest thing to do. Give me a second, I'm gonna check my streaming status. I see some connection-y things happening. Looks okay. Okay, yeah, that's interesting. Not movable. TB packet, not movable. I think that's fine. I think we're already heap allocating our packets. And this is interesting. This syntax here, like this is a comment. This is a string. Oh. So this type mappings array here, these elements are 2-element subarrays and or tuples. I'm always forgetting the syntax in Zig for tuples and arrays and structs is all very similar, and I'm always forgetting. These are 2 elements though, and these are 3 elements. The third element is a multi-line string in Zig with a comment. All right, so what I want to do here is just make sure that all the things that are being exported here are the same things as over here with the same names, and just copy paste all this stuff over. This all looks like it's going to be looks like it's going to work. So the Rust array here is exactly the same as the Zig array here. In Rust, we could make these dot comments, you know, three slashes, but not really important. I want to undo what I did here just really quick. Look at all of these names and make sure the names are not changing. You can see here we have a new TB init status. And there's some new types here that we didn't use before for logging and stuff, but it's fine to go ahead and omit them even though we're not using them. Okay, resolve Rust type, resolve C type. I don't remember offhand from reading the diff before whether this has changed. And in fact, let's go set up a git diff to let us look at all this on the command line without switching back and forth from the web browser. So we basically need to find the range of this PR and do a big diff over it. So I want to copy this. That's not the right thing to do, not the right thing to click. Click this thing. And I'm not going to show you my screen real quick, but I'll show you before I hit enter. Git diff of the parent of that thing up to here. All right, now I'll go switch back over so you can see it. So I'm basically setting up this diff on my command line. This should be the full diff of that PR. I can say git stat, and this is all the stuff that PR changed. And what I care about right now is a TB client header. I just want to be able to look and see that real quick from the command line. Source clients, C TB client header.zig, ambiguous. Maybe I need to put this before the commits or something like that. Source clients, CTB, can't autocomplete, that's a bad sign. Ambiguous, unknown revision, or path not in the working tree. Oh, my relative path is wrong. I'm already in the Rust subdirectory. There we go. So what I'm curious right now, why I set this all up, is because I want to see this. So here, before we were talking about some of these elements in this type array have 3 elements now, and that's because they have possible comments. And we need to reproduce this behavior in our bindings generator. So probably I can just copy this wholesale. And where did that live? Line 174 doesn't exactly correspond to our buffer. It lives right. Oh, none of those places. None of those places. It's in resolve C type, which for us is resolve Rust type. No, I'm wrong. It's in main. It lives right here. All right, so this is the loop where you emit every single type. All right, does this make sense for the Rust bindings? Looks reasonable to me. And again, a lot of this we're just going to be blindly trying to do the right thing across several different files, and then, trying to rebuild the Rust bindings. All right, this thing changed. There's a special case here for one very specific Zig type, which is pretty gnarly. This lives in main again. And I think we didn't reproduce this in the Rust bindings because these fields don't actually exist anymore. I remember we had a big discussion about this where it's like, this looks like dead code. And we didn't reproduce this code in the Rust bindings. Let's go look at this TB operation and see if these fields exist. It's very interesting. Okay, this TB operation lives inside of tigerbeetle.zig, which is kind of like the core model for Tiger Beetle. And here it's called operation. No, does not actually live in tigerbeetle.zig. Let's go look in something else real quick. TB client exports, no, not exports, TB client.zig. Operation is in state machine.operation. State machine lives in state machine.zig. Const operation. This is an enum. And remember that code is a special case for these fields and or variants, and they still do not exist. No reserved, no root, not register, no register over here. Okay. So as far as I can tell, this is dead code. And I made a to-do to come back to this and, maybe fix this later separately from this PR because it's a bit of a yak shave, but it seems like dead code to me. All right, let's arrange our windows again and go keep looking at this diff. All right, again, this stuff changed. This is kind of unfortunate. This is just kind of a minor syntactic fix. This has no actual semantic meaning here. Okay, we got to go do the equivalent things in all the Rust function definitions. Interesting. Client used to be called out client, now called client out. This is more Tiger style. All right, let's just do these one at a time. Client out. Now it's called client out. Out client, client out. And this is in Rust, this is a mutable pointer. This cluster ID, interesting. This did not change, but I have it defined in a way that is wrong. I have this defined as a pointer. This looks like ABI wrong, like wrong. Maybe this changed elsewhere between my PR and it changed in a different PR between my PR and this PR, but this looks like super wrong. This cluster ID is 128 bits cast to a byte array by value. Very weird. Anyway, this looks very wrong. Let's take that. And this is a by value array of U8s. Oh, that's annoying. My auto indent doesn't understand. So I have some kind of Zig mode installed in my Emacs, and it just doesn't understand what's going on here. That's pretty gross. All right, so the cluster ID is changing. This should result in a type error, though, when we finally hit it in the Rust code, so no, not a big deal. Should lead us directly to it. This name here has changed, and that probably also impacts the... Ooh, this is getting tough to hold all this in my brain. So if we look at init, okay, we don't have an equivalent of this client out name in the Rust API. That's helpful. Don't have to go change that without any compiler help. So that cluster ID has changed. This address pointer, we're just gonna have to look over every single one of these things with a fine-toothed brain. Same address len. Same completion context. So usize. We don't use this in the Rust API. This completion callback, this changed. We know this changed. This is, so we have 6 arguments. 1, 2, 3, 4. Now we have 5 arguments. Okay. Right. So before, I was totally wrong when I was reading this diff before on stream. I was thinking this TB client was added, but this TB client handle was removed. Okay, so it goes from 6 arguments to 5 arguments. So all we have to do here is remove this, and all this other stuff should be the same. And I don't remember offhand what that is. And the compiler should help us figure this out when we finally get to it. TB packet T, U64, const U8, U32. That all looks okay. And this is no longer a TB status. This is a TB init status. All right, moving on to the next one. This init echo, we don't use at all. Again, we'll copy this change in the cluster along with its comments. This client out, or this out client is now called client out, but otherwise it's still just a pointer to something. And the completion callback, presumably changed in the same way. Otherwise, this function is unchanged. And this is a init status, not TB status. Okay, keep going down. This TB completion context, again, we don't touch this in the REST API. Apparently it used to return a value. Yeah, it used to return a pointer size thing. Now returns TB client status. That's not what the, oh, okay, yeah. TB client status, not init status, TB client status, TB client status. I keep getting confused because the order of return argument declarations in C and Rust is completely opposite. So I keep looking at the wrong space for the types. Okay, this takes this used to take a client T by value. All right, used to be, okay, makes sense. This is now a star mute TB client T. TB client completion context. TB client completion context out. Okay, before it was probably returning this, and now it's an out pointer. Yeah, makes sense. All right, so we got to write another argument here. Completion CTX out. Interesting. Tiger style often says not to abbreviate stuff, but abbreviation right there. This is going to be a star mute usize. As a pointer to something pointer sized. Okay. Pointer to something pointer sized. Oh, this is all so brittle. We don't use this function in the Rust bindings. Knock-yam, good to see you again. On completion context, change to completion context. Let me go look. Completion context. On completion context. On completion. Oh, I'm not seeing that, but I do see this. The name of this thing changed. on completion. Oh, on completion context can change to completion context. Completion. Sometimes it abbreviates context and sometimes it doesn't abbreviate context. On completion context. Notice I'm not seeing what you're seeing. Can you say more? This name definitely changed. It's completion callbacks. Oh, I see it. I gotcha. I see what you're seeing. This is no longer on completion context. That's completion context. And this is not on completion. This is called completion callback. So this is completion context, and this is completion callback. Thank you for the help. Ooh. TB client completion context. Okay, we got that, and I think that's right. But this doesn't return a... Okay, I got it. Init status is only used for the constructors. Otherwise, there's other statuses that are possible. So when you call a destructor, there's only like a couple of statuses possible. Other functions, there's a whole bunch of statuses possible. Makes sense. All right, on client submit. This now returns a TB client status as well. And the compiler is not going to help us with these return values. We're going to have to remember to go inspect all the return values for all these FFI calls. TB client status. Although depending on how they're emitted in the code gen, we might be able to tag them must use in Rust, in which case the compiler could help us. But I think they're just enums, so they're just like numbers. There's no new type there for us to tag. Okay, on client submit. It's a pointer, still just a pointer. Oh, before it was not a pointer, now it's a pointer. So it's a star mute TB client T, and then a pointer to a packet, star mute TB packet. Returns a client status. Seems correct. Yeah, no Siam there. It would be much better for this stuff to be actually code gen. This is so brittle the way it is right now. There's a comment up here that we've seen a few times where it's just like, this is written so long ago that apparently the reflection facilities weren't adequate for it back in the day. But there's another thing we could circle back to and do on stream perhaps, is make all this stuff code gen through reflection. But very gnarly the way it is right now. TB client submit is, okay, submit we've done, that's fine. Client packet dinit. Okay, now that's a pointer. Just star mute. And this returns again a TB client. Yeah, overall, this is these are great changes. This API is much more consistent and readable now than it was before, especially with the code organization. This thing we didn't even have in the code gen before. And go ahead and translate that. We're not using it. But that's fine. Have it for the future. Oh, that's gross. And make sure we put this at the right indentation level for Rust. Seems about right. Now we have to actually make this look like Rust. Let me move that up so it's not blocked by my head. Registers or unregisters the log callback, which we don't use. So this is let's copy that big type name, pub fun. Huh, this function is not prefixed with a TB namespace for some reason. Seems like an oversight. But again, from the PR, it seems like logging is just not done here. I mean, the feature is not finished yet. And this returns not that. Let's see. I've got maybe 45 more minutes. Like last stream, I have a pickleball date after this. Go decompress after the intense stress of coding on stream. Okay, so this callback has to be rewritten in a completely different way. This is easy to rewrite. To do this, I'm just going to cross-reference the other Rust callbacks we have. Rust bindings.zig, because the syntax for doing an FFI a C function pointer in Rust is pretty gnarly. Right here, you see that. So this is going to be, oh, this auto indentation is just annoying. These need to be double indented here. All right, this is callback stood option. I'll re-indent it all later. Okay, and then inside of this, unsafe extern C fun. And I always put trailing commas on my argument lists. Optional. And then this, probably more indentation here. All right, here's our arguments. I'll switch back over to the C definitions here. All right, the first is going to be a TB log level. I'll switch back, make sure we're actually exporting TB log level. TB log level, TB, right there. TB log level. Ooh, and okay, so TB log level. And then some kind of const pointer, star const u8, okay, whatever. And then a u32. All right, that's pretty easy. And then we can I'll try to do this the clever way by removing a whole rectangle. Oops. 2, 3, 4. I'm always forgetting Emacs commands for everything. Delete rectangle. Aha, there we go. And then that is no longer needed. Let's scan this with our eyeballs and see if we think we did the right thing here. So option, all the braces are closed. Callback. TB log level, U8 constant. Okay, that all looks right to me. Register callback status. Okay, I am not sure we've actually done everything here. Let's go look through the diff again. Let's go rediff this file. All right, we did that. We didn't change our imports like that though. Export, we didn't even do this. Yeah. Let's just do this instead. Right up here at the top. That is what we're importing now. And seemingly we don't need that at all. supposedly. We've done that. Done that. Oh, we've done everything. I think we've done everything here. So I'm going to checkpoint this as a commit. And if we did everything right, we'll at least get through the bindings generation. Even if the bindings are wrong, we'll at least get through it. But more than likely, we'll hit some kind of compiler error in that Zig code and have to go fix it. If you're just joining, we're working on the Rust client to Tiger Beetle, and we're doing a big merge of changes that affect our PR. The underlying TB client Zig library has changed just slightly in its interface, but that has a pretty big impact on what we've done here. So we're just kind of struggling through. What is this? Oh, we did. We got through the Zig code generation. So, and now we're hitting Rust errors. Yeah, all kinds of errors we've got to go work through. These are interesting. No value. These names seem to have changed. Interesting. Would not have expected that from the things we've done so far and from what we've seen in the upstream changes. I'll tackle that down the line. Let's go look at what our new bindings look like. Rust. This is our bindings generator that we've been hacking on. And these are the generated bindings. And so we could even maybe diff that file. No, it's not checked in. Okay. This file is generated, and so it's not checked in. But this is the new bindings. Let's go kind of just scan through it and see what we can see. TB client has changed. Okay, there you go. There's our new TB client. And that looks correct. Repr C. Our comments, our new comments that are generated made it through. And our function definitions that we just wrote by hand are down here. This all looks plausible. And real quick, let's just go look at these. Like, why is this stuff no longer correct? Are these names different? TB status, TB status. Let's look up here, TB status. Okay, there's a new init status. Let's go make sure that init status exists. TB init status. Okay, oh, client, wait. Something feels wrong here. No, maybe this is okay. Yeah, so this is the constructor status. Like when you call a constructor, you get back an init status. When you call any other method, you get this one. So the TB init status, I spoke incorrectly before when I was describing how these might work. When you construct a TB client, there's all kinds of possible failure modes. But when you call just some arbitrary method, it's really just like, has our client been de-inited already? Or is that handle, that opaque handle, in an invalid state? That makes sense. All right, and we're getting problems with TB status. Yeah, maybe the issue here is that, so there's TB init status, TB client status. Maybe TB status just doesn't exist anymore. So probably TB status was split into init status and client status. And just all these things, yeah, that looks like what the case. So TB status is just not a thing anymore. So there's more stuff we're gonna go have to change in our handwritten conversions here. Makes sense. Okay, so now the thing that we need to do, see where we are, and just take a step back and decompress for a minute. That was all pretty intense. But everything's kind of going as planned so far. So we read through the PR and just kind of loaded into our brain what we thought was going to happen, and then created a plan. Everything's pretty much going to plan so far. Now we should just need to work through these Rust errors, but then there's, a set of changes here that we hypothesize are not going to be caught by the compiler. We just got to go remember to deal with those. It's especially related to where that client lives, because remember from the docs that client must be pinned. It's not allowed to move, which implies we probably just want to put it on the heap. In Rust, we have some tools that will allow us to say this thing can't be moved, the pin trait, but it is so complex that I don't want to deal with it or force users to deal with it. And it's very easy to just put the client on the heap and be done with it. All right, let's see how much time we have. It's 2:09. Oof. How much more can we accomplish here? So I think the thing to do is, we're not going to finish this all today, which is unfortunate because there's so much stuff to think about that it's going to be a bummer to like sleep on this even for a night. We can accomplish a little bit more, but the thing to do is just work through these compiler errors, I think. And then after the compiler errors are resolved, we'll go back and think about those other issues. Although even as I'm saying that, the issue of where that TB client lives, I kind of want to resolve that. But we're not going to be able to resolve this without help from the compiler, because if we bump this to the heap, that's going to trigger a cascade of compiler errors, and adding those compiler errors to the compiler errors we already have is just going to be a nightmare. So we're going to have to do that later. Yeah, we got to remember we got to put that on the heap. I'm going to make a little to-do list for us. And I'll just go put it right here. To do. TB client T must be boxed. And check all calls for status. I think that's the only things that we've noted so far that the type system's not going to help us with. Those are changes we're going to have to go just manually make. And I'll checkpoint that to-do list. And let's work through these compiler errors for the next 30 minutes or so, maybe 20 minutes, we'll see. What am I running here? Cargo check, okay. This L cargo I have here is just a shell alias that sets up the pager for screenfuls of compiler errors. Nosiam, do you pronounce your nick Nosiam or Nakiam? I was thinking about you over the weekend for some reason. And I was just thinking like Nakiam. It's like a network operations vegetable. Hope that helps. Okay, so here's the first problem errors we're seeing are just, these are code gen errors. We've done the syntax wrong here. Line 319, that's easy to fix. Yeah, that's 319 in the generated code. We're looking for cluster ID. Cluster ID, yeah, we did that one correct, but the other one incorrect. Okay, go ahead and all right, you're gonna be Nakiam from now on. It's just gonna tickle me a little bit. Network operations vegetable. Is a yam a vegetable? Yes, I guess it is. Let's see. Okay, errors. All right, errors. Get focused. I committed, so I accidentally invalidated the build script. Okay, so this is related to the renaming of those statuses. This should all be pretty easy to deal with. Five three. So this is no longer TB status success. This is probably TB init status. TB init status. TB init success. Strange name. In chat, can't reflect function argument names. Oh, you can't get the argument names in Zig. That makes I was gonna say that makes sense. I mean, the names have no meaning at runtime, but the reflection is compile time. Whatever. Makes sense that you can't get the argument names. It also would make sense if you could get the argument names. All right, so this is not a TB status. This is a TB init status. TB init success. I'm just wondering why these names ended up stripping. I know there's some special case here. You can see all the constants are prefixed with the enum name. And then also with part of the enum name again. You can see here there's no status right here. And I remember there being some special code that's like munging these names in that way. But real quick, I just want to look at the C code and make sure we've actually resulted in the same names. Where do these live? C tb client dot h tb init status. Oh, okay. Well, the name looks correct. TB init success. The actual name has that has part of the enum name embedded in the variant name, because these are not names based in C. Makes sense. As long as our Rust names look like the C names, I'm happy, even if they're very unwieldy. These aren't exposed to the user in the Rust bindings, at least. All right, TB init status, TB init success. And we can probably just keep following. We can keep following the compiler errors to guide us to the next thing. Yeah, so in chat, Nakiam is saying that we could embed the file and just, parse the Zig. And that is exactly what we might end up doing for writing our unit tests, because our unit tests are going to want to make sure that our handwritten Rust code is exactly like the ABI, especially for things like enum variants, status variants. We have no guarantees that we've correctly duplicated all of the actual Zig variants into Rust. So when we write our unit tests, we will probably literally end up parsing the Zig code and parsing out all those variant names in a test. It's not production code, but very, very gnarly thing to do. But if you want to have more conviction that the code is correct, got to do it. It's strange that it gave us this unused import warnings from conversions right here. I don't really care about that right now. So line 69, this TB client submit. Got it, okay. TB client used to be a void pointer. So it was a pointer even though it wasn't written like a pointer. Like this TB client was defined as a pointer. And TB client now is an opaque value type. So we need to reference this. 69. So this is going to be star and mute. Is that right? This is all going to end up changing because interesting. So the API wants us to pass around unsafe pointers to this handle, which means we can't just be creating Rust references to it like that. This might be too complex to resolve right now. And we might have to kind of do multiple things at once, like change how this client type is stored while changing how it's dereferenced. Because like there are going to be multiple, this is interesting. Remember this thing, part of the requirements of this API is that this value type, this client handle that's opaque, we're not allowed to move it because we're handing out unsafe pointers to the client library. And so that means in Rust, we can't ever take a reference to it. Just immediate undefined behavior if we take a reference to it while there are outstanding unsafe pointers to it. So really, in order to resolve a lot of these errors, comp time is slow. Yeah, one thing I've noticed, Nakiam, is that Tiger Beetle compilation feels slow to me. Like it's hard to have a point of reference because, it's Zig, and this is basically the only Zig project I've worked on. But the Tiger Beetle code base is small. It's a small project, like maybe 100,000 lines. And it takes a long time to compile. And Tiger Beetle leans very heavily on comp time. So it's really easy to imagine that it's just expanding tons of generics and re-type checking all those generics. But Tiger Beetle is, said to be fast to compile, but not necessarily. As with all languages, when you have monomorphized generics, it just kind of explodes without you really being able to comprehend what's exploding and why. And Tiger Beetle's compile time is surprisingly slow for such a small project. I'm just, chatting with Nakiam about things unrelated to what you're seeing on screen, but the comp time, very powerful, but unsurprisingly it's slow because just doing a lot of stuff at compile time. All right, so the thing we have to do, and we're probably just going to have to wrap this up and do this some other time because this is tough. Have to change how this is stored because we cannot take Rust references to this. And you can see already like there's probably plenty of cases where we're taking Rust references to this. So before we resolve any of those errors, we got to change how this is stored. And before I was saying it had to be a box, but really I don't think that's even going to be sufficient because that box implies, Rust ownership. So really it's just going to have to be like ultimately heap allocated unsafe pointer. And then in the destructor, we'll have to destruct this thing. Let's take extra measures to destroy this in the destructor. Like if this was a box, it would just go away automatically. But because we're going to be handing out unsafe pointers to this thing, we're just going to have to store it as an unsafe pointer and never create a reference to it. Which is a pretty tough requirement for us because it's easy to accidentally create references. But really the only thing we're going to do with this thing is just hand it out. Like we don't have to do anything besides pass it to API functions. But I think I'll have to tackle that in one big go next time. Let's see if there's some other things we can resolve. All these errors are just about what's going on with that client type. Bunch of stuff here. I think the only thing that makes sense for us to really tackle right now is all these wrong names. Let me see what my diff looks like right now. I shouldn't have a diff over here. Get clean. What is this diff? That's correct. We accomplished that. And so somewhere in here, there's like an enum status. Enum status. Yeah, this thing is split into two types. Yeah. Well, Chad, I think everything else is just, too much work, and I am running out of time, so we're going to wrap this up. And I don't want to push this back to the PR because it's in an incomplete state. So I'm going to push this to Rust client merge work. Just to have it somewhere other than my local machine in case I screw up something locally. And there's quite a lot to figure out here still. Well, let's wrap it all up. Okay, so today we've been working on merging upstream into our Rust client branch in order to kind of finally get the PR ready to merge for a final review of that PR. And it's a pretty complicated merge because the client API and the client bindings generators have all changed in the meantime since we initially filed this PR. But what we did was we, read through all the changes to try to understand what they were and what we were going to have to do to adapt to them. And then came up with a little plan of like the order of operations. And so far it's gone pretty cleanly. We haven't needed to we haven't completely invalidated any assumptions and had to back out and completely start over, which is pretty common for a big merge. You can do it multiple times and figure out like the exact path forward. But this has all worked out so far. Next time we're gonna have to figure out how to adjust how we're storing that client, make sure we're doing it in a safe way, and deal with some of those renames. But it all seems pretty straightforward. It's just a matter of, doing the transformations and testing them and making sure everything still works. I think that's about it. My name is Brian Burson on GitHub. This will be on YouTube pretty shortly. All these streams go up on YouTube. I really appreciate everybody showing up today and helping me again. That's so amazing. I'm very grateful for that. I'll see you next time.